Hi students, welcome to week 11. Last week we learned about lists, and this week we're going to be working with dictionaries, which are similar to lists, and I'll get into that in the next couple slides. So again, we'll just get into this flow, this rhythm of posting your assignments, your programs up to our discussion forum by class time on Thursday, and then just comment on 2 of your classmates' code and all of the questions. You've been doing this all semester, so just we'll continue to do this. I think it's good to see each other's code and kind of have that discussion, even though because we're not in class. This will kind of hopefully not make up for it, but give you a sense of connection. And the questions are up on Dictionaries, so do these individually. And as far as the lab and working together, you can team up virtually if that's possible, and you know, work together in the lab. That might be kind of cool, especially since everyone's so isolated these days. It's totally up to you, but I do encourage that, just again for another sense of like connection. So your assignment in your lab on Dictionaries will be due next Wednesday as usual, the night before we normally have class. So Dictionaries. So by the end of this week, you should be able to demonstrate how to create a dictionary and set its items. Also explain how rows and columns of data can be stored in lists, and develop algorithms that loop through lists to compute a result. So dictionaries are a collection of things similar to lists. They're unordered. You can change them. They're indexed, and these indexes can be almost any type, which is different than lists, where the index had to be a 0, 1, 2, 3, or a negative number. But for dictionaries, they can be characters, they can be many different types, data types. So they're used the curly brackets, and to add, instead of the regular brackets that we had for the list, to add items to a dictionary, you use the straight brackets. So there's basically just a mapping set of indices, and they involve keys and values. So each key will map to a value. And this is the function, dict is the function for dictionaries. So here I have I created a variable with a dictionary, and it's cats' names and colors. Joey, I don't know if that's a cat name. The only real cat name here is Taco. It's my friend's cat. She calls him Taco, and he is brown. So what I've done is created a dictionary here. So the first is Joey is the key, and then black with white spots is the values. And Susie is the key, and the blue-gray is the value. And as you can see, it's separated by this, this colon. So if we print this, then I've just created cats, I've just created a dictionary. So the key value pairs. So when you're looking at the key in the Python dictionary, it's similar to looking for a particular word in an actual dictionary. And the value is the corresponding data that's associated with the key. It's comparable to a word's definition that you would have in like a physical dictionary. And the key is what we look up, and it's the value that we're actually interested in. So that's the key value relationship. So you can add items to the dictionary by doing this. So I've got cats, that's my dictionary, and then I'm using straight brackets, and I'm adding this key with cinnamon, which is the value. So if I run this code, this line, and I print cats, you can see that toast has been added to the dictionary. So this is how you add items to dictionaries. Oops, sorry. Okay, so why do we use dictionaries? Well, usually when you're working with data and you're doing data analysis, the data is not always very easy to use. So Python dictionaries make it easier to read your data and to change your data. It's also looking up a key is very fast. Instead of having to go through like a whole list, if you have a key, which is going to be unique to a value, it's a lot easier computationally to find what you're looking for. So that's why we would use dictionaries. So what you will get a better understanding of this by reading through the chapter for this week. And I do want to mention one other thing. When you're writing the programs, the code that's in your book is pretty much telling you how to write these programs at the end. So if you, I mean, you can definitely Google and find different ways, but I think if you're struggling with writing the programs, if you just follow what the code and the text is doing for each week, I think you'll have a better sense. But of course, Googling is always an option there too when you get stuck. So I think that's it for my little lecture. Next week we'll be doing tuples, and then we will the last 2 weeks we're going to be working with. We'll do a little bit with files next week as well, and then we're going to have our last two weeks, which we're going to have our hackathon, and we're going to be hacking with CSV files and then hacking with JSON files. And I've got some pretty cool, I think they're cool, activities and data for you to hack with. So I'm looking forward to that. So I will be meeting every week, every Thursday on Zoom from 2 to 3:30. So if you want to stop by, if you have questions on anything we've covered so far, or if you just want to say hello, that would be great. Okay, so I can also do individual Zooms. And if you're having trouble with your code, your program, and you get to the point where I just can't, it's not working, I would prefer if you emailed me your file so I can get my hands on it and look at it and see if I can help find the bugs. I won't be able to do that at our Zoom meetings because it's not really it won't be that productive because I have to like look at your code and try and figure out where the bug is. So yeah, so that's that. So if you have any issues with what your programs are doing or not doing, just shoot me an email and let me get my eyes on it, my hands on it, and see if I can come up with what's wrong. All right, so having said that, I hope to see you. Drop in on the Zooms, and yeah, that's it. Bye.